This lab deals with density and Archimedes, well, more specifically Archimedes Principle. Your objectives in this lab are to obtain the density of 3 fluids using hydrometers, and then you're going to calculate the density of unknowns. And the way that you are going to do this is by using Archimedes Principle. So if you remember, Archimedes was this guy. The king gave him a crown. He walked over, hops in the bathtub. And what's he see? The bathtub water rises. So then he screams Eureka and goes running around the town. What he actually discovered, and what Archimedes' principle says, is that the buoyant force acting up on an object equals the weight of the fluid displaced. Weight of the fluid displaced. In formula terms, In formula terms, we would be looking at buoyant force is equal to density of the fluid displaced, times G times the volume displaced of the fluid. So this is the important equation that you need to know, right here. And you're going to be using this. Your lab is going to manipulate this to find out densities of unknowns. So the first thing you need to do is to figure out what is the density of this fluid. Now if you remember, density equals mass over volume. So if you have a more dense fluid, if you push the same volume away, you'll push more weight of fluid away. Right? So same volume of a more dense material weighs more. Has more mass, weighs more. All right. So one thing that I want you to notice is that you have to pay attention to the hydrometer labels. They're on the plastic case. So what happens if you start with a label? This is a glass tube. Glass can break. So start with the lower one, and what'll happen? You put the lower one in. If it floats up above the scale, right here, which we're going to zoom in a little bit, then you need to go to the next one. If you start with the heaviest one, it sinks. All right, because it's meant to measure the density of a more dense fluid. So the way this works, pushes fluid away until this starts floating. All right, displaces a volume of floating. If it displaces more volume, this part goes down deeper, and it'll give you a lower density because it had to displace more fluid. Taking a closer look at this as we zoom in, you will see that the mark is right here, and you always want to measure, just like in chemistry class, from the bottom of the meniscus. Now, we have given you 3 fluids. We've given you water, we've given you methanol, and we've given you sodium acetate, so we're going to call that sodium squiggle. These are not pure. Unlike chemistry, we put them back into the thing, so these are not their real densities. Hence, why you have to measure them. So when you're measuring them, your group measures one, and you're going to average all groups. All right. That way, if you measure it, odds are you're going to get the same thing over again. So very closely, you will see that this is 1. This is in grams per cubic centimeter. So when you measure this, the bottom number is 1 for this particular. This would be the 900 or 0.9 to 1.00. You will get 4 decimals. Because the mark on each of these, this little mark right here is a 5. This is 90, so this would be 0.9.95. So you get 0.95, let's say it's right here, and then you'll get an estimation number. Don't forget that estimation number because that's where a lot of your error is going to come from. Once you have the densities of the fluids you're going to immerse things in, we're going to figure out the densities of these unknown items right here. So this is your balance right here. It is a centigram balance, goes to the 100th of a gram, which makes this pretty accurate, which means you measure to the 0.001 of a gram when you measure this. the pan right here should always be on because this balances out your mass balance. So you hang this unknown here, you'll take its mass. Then you're going to put the mass in a fluid. You're not going to use sodium acetate, so you're only going to use H2O and methanol. So a couple things to note about this. Its mass should appear less, and the way this works, this is a balance right here. So if you remember chapter, oh, I don't remember what chapter it is, but here, I remember what's in the chapter, just not the chapter itself. This is your fulcrum, all right? And you will see that here is a force pushing down. These exert other forces down, and we call these torques. Remember, torque, if you have a radius force, they exert torques. So the way this works is just a static equilibrium. The sum of torques equals 0. So what's going to happen is when you have this buoyant force acting up here, it means the tension in this string is going to decrease, which means this measurement is going to be less. All right? So your apparent weight is less, or your apparent mass is less. The actual mass is not less. Couple notes, the pan right here, always on, and there is this platform right here. This platform raises and lowers, and it is so you are not massing the water. So use this platform right here. It is important. So if you go through your lab handout, it will walk you through how to go from Archimedes' Principle to figuring out using the density of the fluid you have, density of this fluid, the mass of this in and out of that fluid, and you will calculate the density of this unknown. And you'll compare those to values online. Couple procedural notes, just to recap. Always start with the smallest number on the hydrometer. Smallest number. That way it doesn't fall to the bottom and break. The pan on the balance is always on, and everything should be submerged completely. Note, you are going to find the density of wood. Typically wood floats. So what you need to do is you need to, this is your block of wood, you need to tie a lead mass to this. Boink. And there you go. And now the lead will sink the wood. Tying knots is probably the hardest part in this lab. So what I want you to do with this, follow your lab handout. There is another equation based on how to account for the density of this lead and to calculate the density of wood. Couple notes on data collection. Remember, average all the group's densities for the fluids, and make sure you are always taking multiple measurements in every fluid. There are a lot of measurements in this lab. Error. For your error, where can it come from? Well, it comes from all of your measurements. So you're going to propagate error through your measurements and through each formula. And you've had practice doing this, but I am more than happy to help. And then you're going to compare densities for your unknowns to the actual. Now these would be the densities of the solids. Because the fluids are impure, you have no clue what those densities are. None of us do. I don't. We just put it back in the bottle and eventually it gets diluted. So there's that. But the solids, however, we actually know what they are. I would use the internet to find those. Or a CRC if you happen to have one lying around. So wrap up, you're using Archimedes' Principle to calculate the densities of some unknowns in multiple fluids, and then double check, review those procedural notes so that you don't break anything or you're not sitting there trying to figure out how pieces go together. If you have any questions, just let me know, and I hope this helps. See you in lab.